Day 337 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2062, count vowel substrings of a string. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. A substring is a continuous, non-empty sequence of characters within a string. A vowel substring is a substring that only consists of vowels A, E, I, O, and U and has all 5 vowels present in it. Given a string word, return the number of vowel substrings and word. All right, y'all, that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have word equals a string A, E, I, O, U, and U. The output is 2. Explanation says the vowel substrings of word are as follows, underlined. We have A, E, I, O, and U right here with just one U. That's one substring. And then we have A, E, I, O, U, U with 2 substrings, which is the whole string. So we return 2. It's important to remember we're not returning the substrings themselves. We're just returning how many substrings there are. And in this case, there are 2. So we are returning the number 2. Now let's go ahead and take a look at example 2 where it gives us a case where there are no valid substrings. So in example 2, we have the input word equals a string. It says unicorn, Arihan. The output is 0. Explanation says not all 5 vowels are present, so there are no vowel substrings. So we need to remember that all 5 vowels have to be present. And in this case, all 5 vowels are not present. As you can see, there is no E in this entire string. So it's impossible just off of that to have a substring that contains all 5 vowels. Now let's look at example 3 where there are multiple or 7 different substrings we can create. So in example 3, we have the input word equals a string C, U, A, I, E, U, O, U, A, and C. Output is 7. Explanation says the vowel substrings of a word are as follows, underlined. First we have U, A, E, I, U, A, I, E, U, O, U. Right, because we need all 5 of the vowels, so we cannot stop until we see this O. We have most of them right here, but we still need this O, so that gives us our first substring. Then we can make another substring by just including the extra U at the end. Then we can make another substring by including the extra A at the end. Then we can create a substring by excluding the first U and doing the same thing over, coming up to O, then we do it again, coming up to U, then we come do it again, coming up to A. Boom. Then we can create another substring just starting from this I where we exclude the first A and come to the second A, and that will give us a total of 7 different substrings that we can create, and thus the output is 7. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult, as I'm sure y'all are aware. So let's get into it. First thing we need to do is we need to check if the word has fewer than 5 characters. And if it does, that means it can't have all 5 vowels because it doesn't even have 5 characters. So we can use a guard statement for that and say guard word dot count is greater than 4, else we can open up the brackets and we can just return 0. Then we could come right here and we need to convert the input string into an array of characters, which will help us to with indexing. So in order to do that, we could just say let word equal an array, open up the parentheses, word. Now we need to define a set containing all 5 vowels. So we could come right here and we could say let vowels equal, it's going to be a set of characters. Excuse me, that should be a capital C. Set of characters. And then we're going to open up the parentheses and we're going to pass in our string. of vowels, which are A, E, I, O, and U. Then we're gonna we need something that's gonna store the final count of valid substrings. So we could just come right here, we could declare a variable, call it result, and set that equal to 0 to start. Now we need to loop through each character's index in word. So we could say for I in word dot in indices where vowels dot contains open up the parentheses, then say word, open up the square bracket I, come outside of those parentheses and open up the brackets. Now we need to start with a full set of vowels we need to find in the substring. So we could declare a variable called remaining vowels, remaining vowels, and set that equal to vowels. Boom. Now we need to iterate from the current index to the end of word. So we can say for ch in word, open up the square brackets I dot dot up to word dot count. And we come outside of that, we're going to open up the brackets. And we need to see if we hit a non-vowel character, then we could break the inner loop. So we could say guard vowels dot contains, open up the parentheses ch, else we can open up the brackets and just say, we can say break. Now we need to remove the vowel from the remaining set because we only need one of each. So we could come down here underneath that and we could say remaining vowels dot remove, open up the parentheses ch. Now if we've seen all 5 vowels at least once, it's a valid substring. So we could just say, come right here, and we could say if remaining vowels dot is empty, we could open up the bracket and say result plus equals 1. Then we just have to come down here and we need to return result just like that. So let's go ahead and give it a run, y'all. Make sure it runs properly before we submit it. Okay, hold on. Can I find remaining? Oh, sorry. Well, we could just add an S to this. And now let's run it again, see if it runs this time. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. And look at that, y'all. 9 milliseconds beats 64.71% of users with Swift. Not too bad. We could get those numbers up, but we'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that because it's easy to understand, and when it's easy to understand, that will help with the learning process so that we can apply this knowledge that we have learned later and further down our LeetCode journey. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.